Guarantee the security towards developers, Google introduced the application signing scheme on its Android platform. The application signing scheme identifies the author of the application, which ensures the integrity of the application and the accountability of developers for the behavior of their product. It also prevents the data from being modified by the third party. There are three APK signing schemes. The initial scheme is based on JAR signing through Java Security API. It only protects part of the APK, and it has other drawbacks as shown in the slides. It consumes more time and resources. Because of that, Google introduced the scheme version 2 on Android 7. The author hash and sign the whole content of the APK with his private key and create an APK signing block in the APK file. When the application is installed, the platform will decrypt the signature and compare it with the hash of the file. Clearly, when we try to modify any part of the signed data, will result in failure of verification. When we update the application, Android verify if it is the same application based on the application ID, and verify if their signature match each other. But version 1 and version 2 scheme only allows one certificate. The scheme version 3 solves the problem by supporting APK key rotation. It gives apps the ability to change their signing key as part of the APK update, which means there is no need to modify the application ID to complete the update of the certificate. The version 2 Plus scheme includes all three schemes, as shown in the slides. The version 2 scheme inserts the APK signing block in the APK file. On the basis of that, the version 3 scheme adds information about the supported SDK versions and the proof of rotation struct to the signing block. Here is the structure of the scheme version 2 Plus, which includes the signer, the version boundary, signature, and public key. Those parameters are used in the verification process. In the verification, we first allocate the signing block. Then we check if the version 3 block exists. If it is the case, then we proceed to verify the signer in the signing block. The verification succeeds only if the signer succeeds in the previous step, and it is the only signer. When there is no version 3 block, then we fall back to version 2 scheme verification procedure, which is similar to scheme version 3.
So, is it secured? Signatures do strengthen the integrity of Android applications to some extent, but still, apps are vulnerable to repackaging attack. Because of the openness of Android, it allows self-signing. Although certificates are included in each app, Android currently does not perform CA verifications for application certificates, which means others can easily repack the whole app and sign it with their key. What Android does is, however, comparing the signing certificates with the one of the currently installed version of the app to make sure that the two versions have been signed with the same key or certificate. So, although others can easily create certificates with your name on it, they won't be able to produce the same signatures as yours, as they don't have your private key. Thus, they won't be able to update or override your app with theirs. or get any special permissions. However, for initial installations, Android can do nothing about it. We have to ensure that we have installed the app from a trusted source at the first place. While we can assume that the official marketplace from platform vendors such as Google Play can be trusted. However, in practice, a number of third-party app stores exist, and it's common that people download and install apps directly outside Google Play. For example, to bypass censorship. Play Store does not allow apps with explicit content on the App Store. A study shows that 5 to 13% of the apps hosted on third-party platforms are repackaged, from replacing existing in-app advertisements to plant backdoors. Here, we proposed several countermeasures against repackaging attacks, combining the result of others. One way is to restrict self-signing, that is, to replace self-signing app signatures with the one signed by CA. Well, it's impractical to replace the certificates of all apps that have been distributed. We can instead display a warning for the certificates from unknown CA, just like what the Windows User Account Control, or UAC, is doing. Another one is code obfuscation. It tries to make reverse engineering much more difficult, but still, it cannot make it completely impossible. The third one is perform code attestation. Trusted Platform Module, or TPM, is a hardware-based platform security solution. It provides a function named remote attestation, which allows app providers to remotely verify that the software is not being changed. It's one of the strongest security measures available for mobile apps.
In this presentation, we introduced 3 different APK signing schemes, including its creation, format, and verification. And we also talked about some potential issues of these schemes and explored several solutions. In the report, we will talk about these topics in detail. Thank you.